Let's take a look at the product rule. So let's say that we want to take the derivative of a function y that is written as a product. Maybe it looks something like 1 plus x cubed times some other factor like 5 minus 7x squared. In order to write down a formula for what the product rule looks like, we're going to have to give a name to each of our factors here. So let's say that this first factor is called f of x, and let's call our second factor here g of x. The product rule tells us that if we want to take the derivative of y, we need to write down our first factor, f of x, times the derivative of our second factor, so times g prime of x, and we need to add on now our second factor, g of x, times the derivative of our first factor, so times f prime of x. And this formula right here is what's called the product rule. So let's use the product rule here to try a little example. Okay, so let's say that we'd like to find y prime, the derivative of our function above, and often we'll just be plugging in a value. So let's then evaluate at the point x equal 2. Well, according to our product rule, y prime is going to look like our first factor, so that would be 1 plus x cubed. And we're supposed to multiply that by g prime of x, so by the derivative of this second factor. So that's going to be negative 14x. That gets multiplied on there. Then we're going to have a plus sign here. We're going to go plus g of x, so our second factor exactly as it appeared in the original function, so 5 minus 7x squared. And we now need to multiply that by the derivative of our first factor. So that's going to be times 3x squared. Okay, and that's our product rule completed. So notice that whenever we do a product rule problem, there's going to be 3 parts to our answer. The first part is this part here where we're doing f of x times g prime of x. The second part is just this plus sign that goes in the middle. And then the third part is doing g of x, so your second factor, times the derivative of your first factor. And that gives us the 3 parts of our product rule. Now, if we go back to the original question, we were asked to evaluate this function here at x equal 2. So let's try plugging in. Now, often I find a calculation like this a little bit easier if I break it up into a couple steps. So I'm just going to plug 2 into each of these little expressions here. And you can grab your calculator to check these values if you like. So plugging in 2, I get 9 times, this is going to be negative 28. And then we're going to go plus. Okay, if we grab our calculator here, this gives us negative 23. And then times 12. Okay, so now this seems a little bit more manageable to plug into the calculator and get a final answer. Comes out to negative 528 for our final answer to the problem. Now, one question that people often have about the product rule comes up if we go back to our original function here. So let's take a look at y. And imagine what happens if we were just to expand this product out. If we started to FOIL this out, we get something like 5 minus 7x squared, and then plus another couple terms there. So imagine expanding it out. You would then have a function that looks pretty nice. In this case, it would be a polynomial, so it'd be fairly easy to then take the derivative of that function. So we could take y prime, and then we could evaluate our answer at the point where x is equal to 2. So in this case, this is another way of approaching the problem. We could figure out what our final answer is here. And you could actually do it this way to check that you do end up with the same answer. So it will certainly come out to the negative 528 that we found before. Now the reason that we really need the product rule is that as we go on in calculus, we're going to start to run into more complicated functions that are written as products. So for example, we might run into the function y equals, say, e to the x times, say, cos x. Okay, we could write it like that even to make it a little bit more clear that it's a product. And here's a classic example of a function where we'd need the product rule to calculate the derivative of this function y. So we're really just practicing the product rule here with some simpler examples before we go on to something more complicated.